Some of you have seen me present before. I was in Toronto. Jonathan, was it 2012, 2013, something like that?
That would be Pete who keeps those kinds of records. It was a while back.
So it was a while back. And just prior to that, I had given a presentation at the 2011 CMG. And the title of my talk was How to Help Developers Finally Find and Fix Their Own Performance Defects. So it's crazy that that was back in 2011. We're in 2019, and I'm still chewing on the same thing. I think it's a really, really tough problem. Our entire industry has struggled. So a lot of times when I connect with people at CMG, we kind of talk to each other and say, how did y'all pick up your skills in performance? And a lot of times we learn that most of us are self-taught, right? And it's a really ad hoc way to pick up skills when we have entire university educations built up around really beefy curriculums. But anyway, it seems like insanity that we keep trying the same things in training performance people, or maybe not training performance people. So that's what this talk is about, and it's about a new approach. So let me get started here. So we've put together a small little testing platform that we call snail4j. And it's really, in itself, this piece of software, it is a simple plan for performance education. And we'll kind of talk, well, that's weird. It's a piece of software. How can it be a plan? We're going to explain that as we get through the presentation here. And really, it's not just how do we train people to learn performance skills, but how can we train people efficiently? How can we do it quickly? How can we get people up and going and knowing how to find and fix all of the biggest performance problems that we see in our data centers today? How can we get people to find and fix those things, but how can we do it efficiently, right? We don't want to spend 10 years training people to get up to speed on performance. We want to do this quickly, right? Maybe weeks or months, getting people to understand what it takes to fix the biggest performance problems in our data center. So that's a pretty big challenge. But we're gonna talk about how we can make some progress on that today. So when we think about my skills, about your skills, and how you came to be able to troubleshoot performance problems and how to fix problems, this is my slide that talks about, well, how did we all arrive here, right? As I mentioned, a lot of us are completely self-taught, right? We were discovering problems. This is on-the-job training. We were discovering problems, and then we went and found solutions for them ourselves. We taught ourselves, we worked with our colleagues to find out how to find the problems and then how to fix them. Okay, and of course, we read performance books, we write performance books, right? I wrote one myself. We have 4-year computer science degrees and coding boot camps. But I've actually done a little research on those computer science degrees, and some of the top more elite programs, like at UC Berkeley or at Carnegie Mellon, they have classes, they have maybe 2 or 3 classes that show you how to use a profiler or how to do kernel debugging, those types of things. But there's no focus on what I see as our main deliverable, right? Our deliverable to our clients is not, it's not the code, it's not the binary. It's a set of processing that runs and delivers well. And our 4-year programs, they don't focus on that, right? There is a lot of methodology on how to deliver the code, but then how to make it run and perform well in a data center, not so much. And of course, We have week-long training sessions from performance experts, whether they're from vendors or whether they're from, other performance experts. And a lot of times you'll pay, $4,000 or $5,000 for a week-long class. And of course, we can also hire performance people from the outside. But all of these approaches have their own serious shortcomings. So finding that performance guru that has been around forever, that knows all the performance problems, well, that takes too long, right? That takes entire careers to build up great expertise in troubleshooting these problems, where we have all kinds of people just starting in our organizations, developers and operations people, that need to understand these problems quickly, okay? And of course, there are performance books, but there are dozens of performance books out there. Which ones should they read? And when it comes to the 4-year programs, again, like I mentioned, there's no room in the curriculum for additional skills like performance. And then when it comes to those week-long training classes, how many people actually show up in those classes and pay $4,000 to get that training? I would say very few organizations can spend the time and the money to make that happen. And when you get to hire performance people from the outside, well, generally there aren't enough people with the right skills. And one reason why I know that is because our team, we do a lot of training here in the United States and in India and elsewhere. We do a lot of interviewing in those places. And the candidates that we get, generally they're not prepared to come in and troubleshoot performance problems and fix them. Okay, and then if you get beyond the problem of, well, how do we teach it, then we still have problems of who are we going to teach? Are we just going to teach a small cadre of people to be performance experts so that the rest of the development community can lie around in their pajamas, maybe barefoot or in slippers, coding up performance defects, right? So are we, the performance engineers, going to break our backs to fix their problems on a regular basis? I don't think that's a great model, mostly because they can create performance defects faster than we can find them, right? And that's a problem. Or are we going to teach to a larger crowd of people, the entire development community? Or are we going to teach performance to the development community so that they can clean up most of their own messes? So in addition to how are we going to teach, we also kind of have to talk about who we're going to teach these skills to. A small group of specialists or to the entire community, the community that creates the performance defects themselves. Okay? So what could possibly go wrong with putting together a curriculum for performance? So let's say those universities somehow found time to put together classes, or maybe those gurus that offer those 1 week $4,000 classes, maybe they brought their prices down. So even if those weren't hurdles, there are still problems in delivering performance education to developers, and maybe even a large group of developers. Okay, you've got the issue of bored, unmotivated students, right? How do you grab a student by the collar and say, look, this is really important stuff? So getting around the issue of bored, unmotivated students, that's an issue. And again, there isn't enough time or money for classes. Even if you have classes in your company, getting everybody together for the right amount of time, for the right amount of frequency, that's a lot of work. Tough to find quality instructors, right? And then there's the question about curriculum. What curriculum are we going to choose, right? Who's going to decide what topics we teach to our students? And then it's even more complicated than that, because if you spend all this time delivering nice performance knowledge to your students, are they really picking it up, right? Are they really understanding, so maybe they heard what you said, but how much did they internalize, and will they be able to regurgitate that performance knowledge back to you? And will they actually be able to find the performance defects and fix them? So these are all tough questions. But what if we flip the problem, right? You can kind of phrase the old approach as, we have experts that impart wisdom. Here's how to find the defect. Here's how to fix the defect. That's kind of the old way that we've been trying to use to teach performance people. But what if we flip that around and said that, what if we had students that were out there actively seeking answers to a very well stated problem? What if we could somehow package for them a performance defect and get it to run on their desktop, and we could ask that student, what is this that's processing, and why is it so god awful slow? What is it? I mean, for me, it's a deliciously open question where you're just like, well, God, I don't know. What is it? What is making this thing so slow? And the entire process of taking that question of, gosh, what is processing here? If you can take that question and take it all the way to the end of troubleshooting the problem, you're gonna run into all of these skills. You're gonna say, well, what tools do I need to look under the covers? What tool is gonna point me to the piece of code that is taking up all the time? Okay, and then you'll get into, well, how do you fix this? How does this code have to be reorganized? How do you make it so the slow response time that we initially saw is a lot faster? So if you could start with this one simple problem, it might be a way to get students started on their own, kind of a self-paced approach to learning things. Okay, so this is kind of my summary slide of where we've been. So on the left here, I won't go over this because I've dwelled on this already. Experts impart wisdom, right? This is the traditional classroom approach to teaching things. And then what I'm proposing on the right is, well, what if we have the students seek answers approach? That's self-paced. I remember in I guess it was grade school, having a self-paced reading program where I could read as much as I wanted. I didn't have to wait for the teacher. I didn't have to wait for my peers to finish books. And if I was slow in something, I could take my time and get to it. Right? It's kind of a self-paced approach. And it's kind of driven by curiosity with this big question I'm talking about posing about, gosh, what is this thing that is processing? And then assessment is a little more straightforward, right? You see, if you can present these problems to the students in a very self-contained way, they can say, well, heck, I found this problem, found this other problem, and then they keep on tackling that. The students who can tackle those problems quickly, those are the ones who are really doing well, right? And that person who's stuck on that first problem and not going too far, well, that's when you can reach in and help. So that's quick assessment. Students can also learn from each other, right? You've got two students working on the same problem, and they can say, hey, what did you do to find out what was processing there? And then optionally, of course, we can supplement that with curriculum. But the neat thing about this aspect of it is we get to understand the targeted need of what the student needs. And like, just for example, right at the beginning, the student is going to say, oh, well, heck, I don't even know what tools to use to look under the covers. And then we've got a great small problem to solve. Okay, we need a bit of curriculum that shows what tools to look under the cover. Okay, so this what I'm proposing here is a student seek answers approach. And And snail4j, don't you love the name, snail4j? Snail4j is not ready for release, but I do have a demo for you to give you a flavor of the direction that we're heading and to show how this can help the problem of finding the most efficient way to teach developers about performance. So on the left side of the screen, I kind of picture this as the hands-off approach to learning performance. In a hands-off approach for learning performance, you have the instructor who kind of starts to, kind of the sage on the stage who imparts their wisdom, right? And the student is there just to listen and think, like these two people in the picture. Okay, let's think about performance a little bit, and let's listen about the theory of performance. But with snail4j, we progress from that theoretical hands-off idea of performance to getting your hands dirty. Not just dirty, but grasping the performance defect. Okay, so it won't exactly be in your, the defect won't exactly be in your hands, but it will be on your workstation. The performance problem will be running on your workstation, and you'll be able to see it, almost touch it. Okay? Just like these two people are holding on to these beakers of that crazy blue substance, right? So my mom was a med tech microbiologist, and she told me when I was growing up that one of her favorite exercises was getting a beaker of an unknown substance just like this one here, okay? And the idea behind this beaker is it's an unknown quantity in a vial or a beaker or something like that, right? And their job was to find out what was in there, right? Is it an acidic solution? Is it a basic solution, right? And there's an entire protocol of techniques used to discover what that unknown substance is. And to me, it's a beautifully, simply posed problem of what the heck is this? What is this? And how do you discover what it is? Maybe it's some substance that's causing an environmental problem. Or maybe it's unknown exhaust from some newly created machine. What is this thing? Because we need to understand more about it. Again, this is the beautiful, simply posed question that helps lead the student down the path of, oh, here's how you discover what this is. Oh, here's how you discover how you fix this thing. So instead of let's tell the student and potentially bore the student, right? If you don't have the right instructor, you're going to put those people to sleep. Let's let the student guide this path to figure out how to fix performance defects. That's what we're talking about here. So what is snail4j, right? It's a piece of software, and it's easy to install load test in a box, right? Of course, load tests are what we use before taking software into production to stress them out, to figure out whether they can handle the real load of the production users. So it's a load generator. Snail4j uses JMeter under the covers, and it's a system under test, right? Which comes with a sample set of defects, and it includes metrics. Just a simple set of metrics that it's a starting point for seeing under the covers. So snail4j is the thing that implements the simple plan for performance education, okay? And it does this by, it's a three-part approach. Part one is, dear student, identify this performance defect. What is this thing? Okay? And the second part of the question is, Okay, well, now that you've identified maybe the name of the piece of code that's causing this problem, explain to me how the optimized version of that code improved performance. And then finally, to really roll this approach out to the entire development community, we want these people to teach others how to use snail4j. Here's how to download it, right? Here's how to run it. Here's how to, click a button to run a particular performance defect on your own machine, right? So it's a little more detailed than that. So I mentioned the 3 steps, right, on the previous slide. So here we have the first 2 steps. And I said we have to identify this, in air quotes, right, this performance defect. Well, the cool thing about snail4j is that we can package up a defect in a little encoded string. Actually, it'll be encrypted. So they can't figure so they can't like break it and cheat, right? Look under the covers to see what it is. So the idea behind snail4j is to take this encrypted token and dial it into snail4j. So you copy and paste this from a simple text document into snail4j. You click a button that says run, and then voila, you've got a performance defect running right there on your own machine. And then that's where the self-led discovery comes, and they have to say, okay, look, my CPU is pegged, or this thing is going really slowly. How do we fix it? How do we find out what this thing is? Okay, so that's the first part, is identifying it. What is the code that's running slowly? The second part, we provide the student with a different encrypted key that dials in the optimization for that performance defect. Okay, so you start with the encrypted key at the top is the defect itself. That's part 1. Part 2 is here's a fix. Here's how to make this go faster. And hang on a second, I need to take care of my dog. Lincoln Dottie? Lincoln Kevin?
You got a good laugh for that, Eric.
Okay, so I'm prepared for the presentation. I've got dog treats here, ready at the wait by my laptop. But I only have 2 left. We'll see how it goes. Uh-oh. I'm not sure if he was smart enough to find the treat I gave him. Okay. Back to work here. Okay. So does that make sense about how we're going to start by saying, dial in the defect, tell us what the problem is, and then we're going to say, here's an optimized version of the code, and tell us what the developer did to make this faster. How has the code been rearranged so they can get their hands on the problem and on the solution?
That makes sense, but later on, and you don't have to answer it right now, but later on, I want to ask you how you're going to apply this in a low-code situation where you're just building applications out of modules.
In a low load situation, is that what you said?
Low code. You know that new thing, which is basically just plugging in bits and chunks of code to each other?
Okay. Yes. So.
With your presentation.
Okay, sounds good. We'll get there, Jonathan. So I mentioned that the load test in a box comes with 3 things, right? It's a load generator, it's the system under test, and some monitoring. Excuse me. So the system under test is really just a menagerie of defects. Okay? So in my performance book, what I recommended people to do is make sure that you look in 4 different areas of the application for defects, okay? And those 4 different areas are the PATH that you see there at the top of the screen. So I want to make sure that the system under test gives the students the kinds of problems that are seen in the data center. Okay, PATH. P is for persistence, right? I would say the largest source of defects have to deal with storing data, normally on some kind of a relational database system. So that's the P in path. The A is for alien systems, right? Systems aren't an island. Almost every system we write is going to talk to other ancillary systems, and generally those are calls over the network. So a lot of performance problems come from some other system, but where our entry point system ends up waiting. And of course, threads are kind of the traditional idea of performance that a profiler is very good at understanding. So, you know, back in the 80s, there was this big movement of, gosh, it's 8 o'clock. Do you know where your kids are? You know, it was kind of a good parenting kind of a public service message. Well, if it's 8 o'clock in the morning, do you know what your threads are doing, right? What are they processing right now? I think that's an important thing for students to understand. And then lastly, of course, there'll be heap and garbage collection issues, GC issues, right? And also with snail4j, you're going to be able to add your own performance defects. So maybe you don't like the list of performance defects that I've included, or maybe that list isn't representative of what you see in your production systems. You're going to be able to add your own performance defects to the system. Well, and what about just on an average coding assignment that you have, and you say, well, we could code it this way with these libraries, or we could code it that way with those libraries. Which is going to perform better? Can we just take 20 minutes to have a look and compare? Snail4j will be a great comparison tool for that. It'll be great for code reviewing performance. And lastly, do you have your own book? Did you write software that comes with that book? Well, Snail4j will be a great tool to showcase that code under load. Right? So there are tons of books that come out with source code, but do those authors show how that code looks under load? Snail4j will be a great tool for displaying that code. I'm not going to go deep into this, but here's a quick picture about the architecture of Snail4j. The blue box in the middle is the system under test. We use what's called Spring Boot. It's kind of an application container, and we've kind of embedded some Snail4j work. Or I'm sorry, we've embedded a Snail4j component called the workload component, and it allows Snail4j to query the load testable code that is inside the system under test. Well, what parts are load testable? Well, you can see in the top where that kind of tan colored oval is. They'll use something called Java annotations. Java annotations are just a great little way to label a piece of code with something. And what are they labeling it with? They're labeling it with this thing called load, that is something that Snail4j can discover. So here's the process. The developers annotate the code. They say, okay, we want to be able to load this and that and the other thing, and they put the load annotation on just a handful of pieces of code. Then the Snail4j UI interrogates and says, okay, give me the list of all the things you want to load test, and whoop, Snail4j will provide you with that list. And then you get nice little checkboxes that say, let's load this. You can click a button, and live, as you click these buttons, the load is turned on and it's turned off. So you can switch. We implemented this way and that way. Which way is faster? We'll click a button to look at it this way, click a different button to look at that way, go back and forth. How does the performance compare? One's faster, one's slower, okay? And so a little more about the architecture. We include a database that can be used to see, okay, when you have a slow query in the system, what do you see under the covers, right? What is it that points to that particular query as the problem? We also have an application called WireMock, which is kind of a back-end testing harness, and that will be for testing problems with alien systems, right? You can simulate god-awful slow back-end requests using WireMock. And over on the left side, the big A in kind of the red shield, that shows that we're using AngularJS for the user interface. And so now it's time for a quick little demo just to show you how we've progressed so far in snail4j. So I think this is a good time to stop and ask if there are any questions before we jump into the demo. And Jonathan, if you could help me with how much time we have left as well.
We've got a good solid 20 minutes.
Okay, great.
Hang on just a second. Let me just see if there are any questions. So far, there's just that one question about low code. I suppose you could just plug your low code in here. The question is, what do you do about it if the answer is you need to modify the low code components that you've used?
Okay, so tell me again what you mean by low code.
Okay, so it's a phrase that we're seeing in the industry a lot these days. And I'm just going to pull it up. So basically what it is it's kind of like library or module development.
Okay.
So instead of writing their own code, what they do is they just pull processes and modules together to do what they want to do. So it's kind of like coding for non-coders.
Okay, I think I have the picture, and I'm gonna rephrase it just so that you know that I understand, or whether I understand. So when you're using a body of code that probably doesn't belong to you, and you incorporate that in your code, and maybe you have some orchestration that says, okay, let's invoke this component, let's use that component. How do you go about dissecting who's to blame for the slowness? Is it my little bit of code that invoked this larger component, or is it the larger component itself that's slow? Is that the general idea?
Yeah, and when we talk about, right at the beginning of your presentation, you were talking about developers creating performance problems faster than performance teams can fix them.
Right.
In a world of low code, now your developers aren't even developing their own code. They're just grabbing chunks of code and slapping them together to achieve function with probably little to no attention to performance.
Yeah, that's a great concern. And I kind of have a two-part answer. The first part of the answer is someone has to be responsible. Someone has to be responsible for the customer, for delivering the code and providing the customer experience. And it's kind of the last person who touches the code who ends up being that one, right? The one responsible for making it all happen. Would you agree?
Absolutely, which is typically going to be your operations staff.
No, that's a good call. They often get shouldered with that responsibility. And I think about a code review, or even a design document. I think a comprehensive design document would say, here's how we plan on making this thing work, right? Here are all the components. And design documents really need to include, and here's how we're going to detect problems with the technologies that we've deployed. Are we going to, and really it comes down to monitoring. And people, and maybe I'm not using that word correctly, but just having squiggly lines that point up and down, oh, the CPU is high, your system is about to crash. How helpful is that? Okay, so yeah, it's helpful that you know when the problem is going to happen. That's great. But how do you fix the problem? How do you point to the thing under the covers that's causing the problem, right? Because it's our responsibility to go in and rearrange something, right? Are we going to rearrange configuration, data, or code? One of those three things, right, to fix the problem. So if you are in your low code situation, you're embracing some set of technologies. Maybe your low code is written in Java, right? Maybe your low code is written in C or Perl or Go or Ruby or something. When you are the one that embraces that technology, you also have to have a plan for pointing to the issues. Okay, I work at FIS. We have hundreds of financial services applications. The group I work with, we work with at least several dozen of them. But we also work with vendor applications that our employees use. Like, for instance, time tracking, enterprise time tracking software. And our group has reached under the covers of vendor applications to say, hey, we're having problems running your software because of this thing right here, right? And we use our own tools, point under the covers of their applications. We get on the phone with them and say, hey, look, this is painful for us. This is our pain point right here. Could you help with that? So does that generally answer your question about how we should proceed in the low code situation?
Yeah, I think so. The answer is that you have to basically build performance into your SLA, and then prepared to point out where the performance pain points are.
Yeah, you have to know what tooling to bring when you choose a particular component in kind of the low code situation, I think. Okay, any other questions? Okay, let's jump into a quick demo.
We're good to go here.
Great, let's jump into a quick demo. Close that. Okay, that's not pretty. Let's go here. Okay, so one thing I